on this episode of Hardcore Meteor. Meteor aliens. What is it, Area 69?
The meteor aliens have crossed the atmospheric border and have been apprehended. Requesting your presence for integration, sir.
Okay, I'll be there as soon as I can. So, we have meteor aliens, okay? Who are you? Where do you come from? Let me see your green card. Are you just gonna sit there like a bunch of rocks? Okay. Only one thing left to do. Full body cavity search. Roto-Rooter. Deep and hard. And then afterwards, we'll check for fusion crust and fingerprints. It's George. And after a little episode of Hardcore Meteor, you got to have a little bit of fun because I don't want to make these videos boring. Okay, but getting on to the serious note, okay, I'm going to give a little lesson here. And it's for experts and NASA and everybody else out there because they don't know, because they didn't look for whole space rocks. Okay, and I'm going to show you how I know that these are whole space rocks and what's going on here. There was a culvert that we had replaced that had been there like 100+ years or whatever. Some of the rocks that I pulled out or that I found after the rocks were put back, they were dug out of the bottom and they were put back. I found a whole bunch of different ones that were under the culvert. If you'll notice, you look at this and you look at these in here. Okay, this is a non-magnetic rock. Okay, but it's all burnt. Okay, the earth doesn't have natural rocks like that. They just don't. It looks like that, but the inside broke open and that's what you get. The reason why I say that they're space rocks is because of this. I broke this one open and this is the stuff that I'm dealing with. And people don't believe. This is a real old rock of fusion crust. But you look on the inside, it's burnt. It got hot all the way down in here. This is black from being burned. And whatever this stuff is on the inside, I don't know. And these little shapes here and stuff in it, I'm not sure what it is. There's this funky looking one. The gray and the black and the yellow, totally bizarre. We're going to go to some other things here, and I'm going to explain something. I'm going to explain something that experts and that meteorite people don't know about, and that people at NASA don't know about because they've never looked for whole rocks, so they wouldn't even understand this stuff. So it'll be like an education for them. This right here is a piece of metal, but it's in rock-shaped form. But this thing is solid metal. Now, I don't know of any earth rocks that we have that are solid metal like this. These bizarre ones. And this on here is what's left of the fusion crust. This brown stuff. Okay? Some of these rocks didn't burn. I'm going to explain why some of these rocks didn't burn as much as they should have, and some burned very little, and some have lines in them, and we're going to get to that. That is packed with unmelted olivine on the outside. Green olivine on the outside. Now, I got a magnifying glass and I can see this. If I had the testing tools and I had microscopes and stuff, I could really prove my point. There's this one All these lines in it. All these lines. This thing went through the mesosphere. Now, the reason why it's in as good a shape as it's in is because it didn't get as hot. Somewhere along the line in the 1833 meteor shower, the temperature dropped in the mesosphere and a lot of these rocks got through. Now I'm going to show you the difference. Okay, this one right here, you can look at the difference in the bumps in it. It's still really brown and a little bit black from the fusion crust. But you look at the difference, okay? This is what happens when a rock goes through the mesosphere. A volcano does not do this. This is caused by air pressure. This one, the reason why it's got lines and it doesn't have the little divots and stuff like this one does, or whatever you want to call them, is because this one burned longer. But still, even this one burning as long as it did, it's not hot enough to melt the rocks. And this is the point that I've been trying to get across to people. We're going to go to another one here. And the colors on these. But you'll look, this one's got the same, it's got the same lines too. And you'll see there's no lines on this side. And I don't think there's any lines right there. Which means it was probably traveling like this. But I can only speculate and guess. And then missing areas like this, the rock's missing its coating. Okay? That's why you got these big bald spots right here. The rock's missing the coating on the outside. But some of these rocks, like I said, I'll pick them up and I'll show them to you. You look at these. There is no earth rock like this. I've looked plenty of rocks up, and I've been studying this stuff. There's no rocks like this with gray circles in them, light gray, dark gray. And the bizarre color that it has. And I'm not even sure what it is. This one's, you got me. If you're an expert, you should know what this is. But the reason why the experts and NASA and nobody knows what these things are is because nobody's ever tried to look for them. So they got a half-ass education. Anyways, this is red. It's got a lot of red in it. The brown is the faded fusion crust, but you got all this red in it. It's red and it's a white gray. It may be, I don't know. Now we'll go to the last three. I've looked this stuff up online, and like I said, we'll go to this one, okay? This one had a green, this one was probably solid green or something at one time. And this is a crack from impact hitting the ground. But the 1833 meteors weren't going that fast. Otherwise, you wouldn't be able to count 240,000 of them if they're traveling at a regular speed. And this is the point I'm trying to get across to people. But this weird crusty marshmallow feeling on the outside shows up after the rocks dry and they come out of the creek. It's got this weird like white marshmallow coating. And this one too. This one's a weird color. And the color changes in the coating. You can't see the coating when it's in the water because these right here, these rocks have never ever been exposed to water. Now, when a rock is a whole rock from space is not exposed to water, it's not used to water, and the earth and the atmospheric air and stuff we got here, because it's been somewhere else, it's like the water like shocks the rock. The rock doesn't know what the water is, so it doesn't know how to react. So that's why it'll basically like change a different color, and then when it dries, it'll go back to what it normally is. But if you look at all these rocks, this is the way these rocks normally are. They usually have probably some kind of a light white coating on them. Maybe blue, I don't know. But I have found other rocks like this that did the exact same thing. And my point is I looked at every one of these rocks. You can't find these rocks online. And in my almost 60 years of living, I've never seen any rocks like this. Now, I'm telling NASA and experts, there are whole space rocks here on Earth. And if that's the case, you look at these rocks. You look at these rocks. You're not going to find fusion crust. You're not going to find fingerprints. You're not going to find some rocks. You're not even going to find magnetism in. And the reason why you'll find some rocks that have no magnetism at all whatsoever in them, it's because they come from a different planet or a different moon or possibly a different solar system. Because you don't have rocks from every planet and every moon in this solar system, and you definitely don't have them from the other solar systems. So you don't know what the rocks are like there. You have no idea. You have no idea what the colors are. You have no idea whether there's solid metal rocks. You have no idea what some of them are composed of. I do, because I've broken open some of these rocks. I know what they're composed of, and I know how hard some of them are. But, like I said, you don't want to listen, and that's fine. I'm going to continue doing what I'm doing and my studying, my research and everything. And then maybe after a while, hey, when it comes down to it, some of the stuff that I'm saying, maybe people will figure it out. But if this is true, then all the stuff that you're telling people about meteorites goes out the door. Because a whole space rock isn't going to have fingerprints. It'll look like a regular rock. Some of them won't have fusion crust. The ones from 1833, some of them won't have fusion crust. The temperature in the mesosphere from being polluted with over 1 million meteors in an 8-hour period dropped the temperature. So it's going to have a lot harder time causing friction on the rocks. And and that's about all I can tell people. And I know for a fact that there's some rocks that came through there, no damage at all whatsoever. They didn't even get burned. And I'm not so sure that what some of these rocks are on the outside, I'm not sure what they're made of. I'm not even sure if the mesosphere is gets hot enough for them to burn, because I'm not sure what they're made of. They're really weird funky colors. And these things, the only damage they got is from hitting the ground. The rock basically doesn't have any damage, but it's got that rough marshmallowy feeling. If this requires more than 3,500 to 4,000 degrees to melt or cause damage to it, then when it goes through the mesosphere like this, nothing's going to happen to it. And I'm telling people that. It's common sense. It's common sense. If you get debris from a supernova that burns at almost 10,000 Kelvin, which is almost 50,000 degrees Fahrenheit, the mesosphere is 3,500 to 4,000 degrees when it burns rocks. Okay, if something comes in there is used to 45,000 degrees, do the math and figure it out. It isn't going to touch it at all. Now, all this foolishness and stuff that people have been shoveling around for years and years and years, this shit's going to come to an end. Because this is going to change everything. And if you don't think whole space rocks can make it to Earth, you're wrong. And that's all I have to say.